Gangasani, and I'm here to explain the concept of visual question answering and its investigated applications. Before that, we'll go through the concept of question answering. This is a system which enables user to retrieve extract answers for questions posed in natural language. There are two types of question answering, text based and visual question answering. The difference between the two is that both search and reasoning is regard the content of image and text. And text based is a longer studied problem in natural language processing. So that is a different story. Coming to the visual question answering, it is a exciting new field which combines artificial intelligence, natural language processing, and computer vision. For both image captioning and video summary, the semantic information is entirely contained within the visual content itself, so there is no need for any additional text. The difference with the VQA is it takes the same semantic information along with the natural language question and produces the natural language answer as output. The idea behind VQA is an AI implementation that has the ability of humans to extract and communicate the information in the natural language using the visual medium. Recent studies have been concerned with understanding visual question answering by focusing on different aspects such as image based reasoning part, language processing module, or any way to combine the two types of knowledge. Here, the natural language processing in VQA is to understand the natural language question and generate the answer accordingly with the results obtained from the computer vision tasks. In one of the surveys by Manmathan and Kaur in 2020 have classified the CV tasks and NLP tasks accordingly. The CV tasks are object recognition, object detection, attribute classification, scene classification, counting, activity recognition, spatial relationship among objects, common sense reasoning, and knowledge based reasoning. And the NLP tasks are tokenization, sentence boundary detection, syntax parsing, semantics, sentiment analysis or opinion mining, word sense disambiguation, summarizing, aggregation, sentence generation. And in this diagram, the visual question answering takes the image and natural language question along with a hint, and it is passed through the VQA system. And internally, the image is passed through the CV tasks, and the visual features are extracted from the CV tasks. The question and a hint is taken and passed through NLP tasks, and it extracts the textual features from it. Based on the textual features and the results obtained from the CV tasks, it generates a natural language answer. Here, an pizza image is displayed along with a question, is this a vegetarian pizza? Along with a hint, this pizza is full of mushroom. This is optional one. Even if they don't give, it calculates based on the algorithms and generates the answer, no, it is a ham and mushroom pizza. And some of the applications of visual question answering are medical VQA, VQA for visually impaired people, VQA in video surveillance scenarios, VQA education and cultural heritage, VQA and advertising. Before going deeply into that, let me give a glance explanation about it. Most of the researchers focused on methodological purposes that includes helping blind users to communicate the pictures to provide a blind person assistance execution of trivial tasks. Caffel and Kennan in 2017 have proposed advanced image retrieval without using any image metadata or tags. Most of the surveys are performed on general purpose dataset that can be used in real world applications. As a matter of fact, tackling a specific application domain also propose suitable related datasets. This article mainly focuses on concrete applications of visual questioning answering and its domains and the experiments that are presented together with the exploited datasets. And it also explains you about the challenges that they faced. Coming to the medical VQA, it takes the AI based medical image and solves the related medical question answering. It is mostly used for diagnosis and like a computer based second opinion. The approach is limited and conditioned by the availability of dedicated database including medical images of possibly specific type and related question answers. These requirements are first addressed by ImageClef 2018 evaluation companion for the medical domain visual question answering pilot task, and then again in 2019 with even larger datasets. The first ImageClef 2018 dataset contained 2,866 medical images and 2,278 of which used for training, 264 for testing and 324 for validation, along with 6413 question pairs. The second ImageClef 2019 dataset contained 4,200 radiology images as well as 15,992 question answers. Two more datasets, namely VQA RAD and Path VQA, was proposed by Low et al. In 2018 and He et al. 2020 respectively. Some of them proposed datasets and medical VQA based on the deep learning approach, class and classifying generative model, and transferring and multitask learning with a modular pipeline architecture and a deep transfer learning approach. And there are many other researchers who have presented many medical VQA models to answer the question answers based on the AI based medical images. Here we have an example for that. This is a city image which takes a natural language question. What does transverse CT image demonstrate? Then it produces a natural language answer based on this CT image. Focal defect in inflamed appendical wall and periappendical inflammatory stranding is the output that is generated by a VQA when a CT image and a natural language question is passed through it. And the next field is visually question answering for visually impaired people. The objective of this is visually impaired people gets help to live without any visual barriers so that they can get the daily questions answered. Assistance to blind people is among the objectives of several VQ applications. Possible scenarios are the spot an empty picnic table at the park or to locate the restroom at the end of the room. These 10 years has a fast evaluation which led from the use of volunteers for answering blind people's questions to automatic analysis of scenarios using images and related questions. In a recent survey, Gurari et al. 2018 proposed a dataset which contains 31,000 visual questions originated by blind people who took a photo with their mobile phone and recorded a spoken question about it. And an iPhone application named WizWiz, who was proposed by Bigham et al. 2010, allows asking a visual question and obtaining a answer in nearly real time. Anderson et al. Proposes a combined bottom-up and top-down attention mechanism in which the question is analyzed by means of GRU and image is processed by a CNN. Vizetel in 2019, here the authors exploit a reinforcement learning model in order to help a blind person to navigate the street. This is an example of a tennis shoes. So a blind person taking a photo and asking, are these my orange or blue tennis shoes? Then the visual question answering system takes the image and the natural language question and produces the output as those tennis shoes are orange. Coming to the next field, VQA in video surveillance scenarios. VQA helps the analysts in surveillance data analysis to summarize the available visual data. The adoption of a VQA in video surveillance scenarios may help operators to enhance the understanding of a scene, thus helping them to take fair and faster decisions. Some of the models proposed for video surveillance are the authors of Lee et al. 2019 proposed a complete platform called ISEE for parsing large video surveillance data. The platform is organized in three modules, which are distributed on the CPU and GPU cluster. They are detection and tracking module, attribute recognition module, and re-identification module. The other author Tour et al. 2019 mostly focus on the soft biometric aspects of question answering in video surveillance, thus proposing C2VQA BORS, which is context and collaborative VQA for biometric object attribute relevance and surveillance. He proposed the three modules, that is C2VQA all, C2VQA image, C2VQA REL. And here we have an example of a surveillance, video surveillance. Here we are asking, what is the man in the red shirt riding? So the VQA system analyzes this image and it produces the output saying he is riding a bicycle. Coming to the education and cultural heritage. The important aspect of VQA is it resembles to human perception. Even if the VQA focuses on different aspects of an image compared to the humans, it is proven that devising a VQA architecture in the same image parts is possible. Some of the applications may include to improve the children's desire to explore by He et al. 2017 developed and tested an educational robot using VQA to formulate questions and start an educational dialogue taking inspiration from the surrounding environment using a faster RCNN. One more application developed by Bonginin et al. In 2020 is for tourists to explore museums and art galleries using visual questioning answering to interact with an auto guide. Here we have an example. This image is collected from the Artpedia. So taking this and passing a question, are we at the beach? Then it analyzes and it says yes. And the last field is visual questioning and the advertising. A user looking at an advertisement not only sees the objects inside the scene but also related text and the relations among the objects, and interrupts all such information within a precise cultural context. The VQA can find a challenging field of application in advertising. The first task is to complete using VQA to understand the advertise and underlining commutative strategy. Some of the researchers that include Hussein et al. 2017 present two datasets for this purpose, one with images and one with videos. The other author of Park et al. 2019 focuses their research on predicting the user's preferences by understanding what impresses them most. They built Real Ad, a dataset of 3747 images with 40 attributes. And another researcher, Zhou et al. 2020, proposed a way to use VQA to extract relevant information about past companions in multiple source data as text and images. Coming to the emerging challenges here, the Cho et al. He is concerning about the data He used 360 degrees images in which the information can be extracted from all the view. Next, Sampath et al. 2020 built a dataset to test modalities in which a image text joint interference is required. Abdunalor et al. 2019 shows how to create auditory scenes and related question answering. And Hosnabad et al. And Bhattacharya et al. have proposed a possibility to emerge answers from multiple possible outcomes. From the point of Tenney and Hengel, they proposed the effectiveness of a VQA, and Lu et al. Proposed a inverse VQA, which is used for question encoder that encodes the image and question, and decoder that from the features of the image generates a visual question. So these were the major challenges that VQA systems are to train the models developed with the relevant data. Concluding VQA is we can say that there should be an attention paid by VQA community in both the concepts of domain specific data and size of the data. Firstly, even though specific data sets are collected, methods are mostly inherited, though sometimes adapted. There is no attempt for boost optimization following a stronger domain characterization except for new kinds of data. Secondly, the size of the dataset is underlying in the general case in CAFL and Canon 2017. Ad hoc datasets seldom reach the huge amount of information requested for generalizability. Hence, VQA community needs to pay attention for these two aspects to reach the performance that boosts the real world domain specific applications. Thank you.